I'm given two squares, and I'm told they're in a certain ratio of the diagonals of 7 to 8. So we'll dig into what that means in a minute. I want to deal with the easier information first, which is that the area of the larger square is 256. Well, I've drawn a larger square over here, and you can see that if the area is 256, how do we get the side length of this thing? Well, you square root it, right? And that's going to give you 16. So 16 must be those side lengths, and if you multiply those together, you'll see you get 256 again. Great, so I know something about that big square now. Now, how do we deal with this ratio information? Well, what that's telling us literally is that this side, this diagonal length right there, is a little bit bigger than the blue diagonal length here. And it can be a little complicated to think about the diagonals of a square, right? That gets into a little bit of trigonometry with square root 2's and 45-degree angles and blah, blah, blah. It's not important because if you know that the ratio of the sides, let's say it this way, short side over, and I'm going to draw these in different colors just to keep it straight with the diagram that I have so far. Short side of the square divided by long side of the other square. That's the ratio. And that's going to be equal to the long diagonal compared to the short diagonal. It's the same exact relationship. Now, the reason I like this way of thinking in terms of side divided by side equals diagonal divided by diagonal is I already know the result is 7 over 8. Okay, so what that tells me is it is okay to stop talking about diagonals because they're in a ratio and they're just going to equal 7 over 8. Then I kind of have my answer just about. Let's call this side x right here, okay? That means x over 16 equals 7 over 8, right? So how do we solve this? Well, you can either just say, what do I need to multiply the left fraction by to make it equal to the right fraction? Okay, that would be quick, it's 2. Or you could do a little cross multiplying, which people like. People like to mess this up, is what they like. You cross multiply, so you get 7 times 16 equals 8 times x. Now, offhand, I don't happen to know what 7 times 16 is, but there we go, 112 equals 8x, and that means x equals, voila, 14. Okay, so x is 14. Now, could you have gotten this by guessing? Sure, because 8 happens to go in pretty well to 16, right? So we could have guessed pretty well that the big square divided by 2 makes the ratio, and then times 2 gets your 7 back to 14 again. So there's guesswork ways you could get to this, but I think the important thing is knowing how to deal with information that's not too convenient, like the ratio of the diagonals. The ratio of a side to a side is the same as the ratio of the diagonal to the diagonal because they're both lengths, right? They both have the same units of distance.